In this video, I'm going to look at the second case in the problems involving trigonometric substitution. Okay, so here I have again the three triangles. I did case 1 in the last video. In this case, we're going to look at case 2, which is a situation where the integrand of the integral has a radical of this form: u squared minus a squared. It could be x squared minus a squared. Okay, I'm using u because sometimes you'll use a u substitution. And the main thing you're going to know here is that draw your triangle, right triangle, theta here, and then you have secant theta is equal to u over a. Notice they're all the same, u over a, except the first one involves sine, the third one involves tangent. And then you let u, or x, whatever's in the problem, equal to a secant theta, and then we continue with the substitutions as you'll see in this example. Let's go through this. So in case 1, I did this problem right here. There's a solution just as a reference. Now in this one, second case, we're going to look at this integral right here, the antiderivative, or the integral of x cubed times the square root of x squared minus 4. Okay, so you can see it fits this form right here, where the variable is squared, and then you have minus a constant squared. Now I want to point out again that when you work in these types of problems that involve a radical, if the basic or standard u substitution works, go ahead and use that, because this one is going to be longer. Okay, using these methods will be longer than the standard u substitution. So in other words, in this particular case, if this x cubed were an x, or a 2x, or x times any constant, then you would just let u equal to x squared minus 4, find your dx, and make your substitution, and if in just a couple of steps you'd have the answer. Okay, but it's an x cubed, so that procedure is not going to work, so we have to do this trig substitution. Okay, so again, using the guidelines for case 2, we let x, in this case, because that's the variable, equal to 2 secant theta. Okay, right here. The 4 would be the a squared in the formula, and the x would be the u. Okay, there you have it. So x would equal to 2 secant theta, and then you take the differential of both sides. Dx is equal to 2 secant, and then I left out the thetas here, but this should be secant theta, tangent theta. Okay, and then what I'm going to do is I'm going to make the substitutions into right here, into the integrand. Okay, so where I have an x, I'm going to replace it by 2 secant theta. Okay, in the integrand here. Okay, so notice here that I got x cubed, x is 2 secant theta, I cube it, and then under the radical I got x squared, so I replace the x by 2 secant theta, quantity squared, minus 4, and then do the computations, and I get this integral right here. Okay, and then to simplify this, here I factor out a 4 under the radical, and I'm left with secant squared theta minus 1. Okay, this formula right here from trig, one of your identities, I can use that to determine that secant squared theta minus 1 is tangent squared. Okay, so I can replace this by tangent squared theta. And then I simply simplify by taking the square root of the 4 and the square root of the tangent. Okay, so the 2 times the 8 then comes out, so the 2 multiplies the 8, I get 16. Okay, and then I got the secant cubed, and then the square root of tangent squared is tangent theta. Okay, so in the initial integral, I can replace the integrand by this right here. Okay, so let's clear this. Remember here the dx is going to be this right there, 2 secant tangent theta. clear this. Okay, so now from here, this is going to equal. Okay, so right here, making the substitution for this part right here, what I got was the integral of 16 secant squared theta tangent theta. And then for the dx, it's theta. For the dx, that's replaced by 2 secant theta tangent theta. And that's d theta. Okay, then we do some further simplification here. I get 16, and then I have secant squared theta, secant theta. That's going to give me a, and this one right here is a cube. Okay, it's a cube. So got a cube there, and then a secant here. So it's a secant to the 4th then theta. And then tangent theta and tangent theta is tangent squared. Theta. And then I got d theta. And I got the 2 here, so this 2 multiplies the 16, so this should be a 32 out here in front. Okay, so now I've got an integral involving the trig functions secant to the 4th theta and tangent squared theta. So you have to kind of play around with this and see if you can do a standard u substitution here. Well, I know the derivative of tangent is secant squared. So let's do this. I'm going to put the 32 out here in front of the integral. So let's break this up. Okay, so now what I'm going to do, I'm going to write this in terms of tangent, because again I'm going to use a u substitution involving tangent. So secant squared is the same thing as 1 plus tangent squared theta. Okay. And that's going to be times tangent squared theta times secant squared theta d theta. Okay. So now what I'm going to do, I'm going to multiply here. Okay, but I'm gonna let u equal to tangent theta. Okay, so du differential both sides we equal to derivative of tangent is secant squared theta d theta. So again, now my next step then is to rewrite this in terms of u. So now we're just using a regular u substitution. Okay, so this tells me then that where I have a u, or I should say where I have a tangent, I can replace it by u. Okay, so let's just simplify this a little bit. Here's a tangent squared. Okay, so that would be a u squared. Here's a tangent squared. That would be a u squared. So if I multiply that out, then this then, let me just save some space here. This would be u squared here. Okay. And then I have u squared here, u squared there. That'll be u to the fourth. Okay. And now, secant squared theta d theta over here, secant squared theta d theta, that can be, that's the same thing as du. Okay, so now everything is in terms, my integral now is in terms of just u. Just a basic polynomial to integrate. So this is just going to be then 32. And then here, then I'll have integrate with respect to u. This will be u to the third over 3 plus u to the fifth over 5. Close parentheses, and then I put my constant over here. Okay, so now all I have to do is, or my next step I should say, is to replace then, go back to the, now I have the integral, but I want to go back to the original variable, okay? But in order to do that, I have to go back to tangent, okay? So what is u? Okay, u is tangent theta. So let me just go up here. Let's say this is equal to, this will be 32. And then this will be tangent theta over 3. And this is to the third, okay, because it's cubed over 3 plus tangent theta, this one's to the fifth, over 5. And then I'll put my constant of integration there, okay. So that's another form of the answer in terms of theta. But remember, you always give the answer in terms of the original variable, which was, of course, x. So let me come back over here then and draw a reference triangle. Okay. So for the reference triangle, this is theta. It was what? It was secant in this case. So this was x over 2. And this is the square root of x squared minus 4. Okay, so now all I have to do then is right here, this is actually the answer, but it's in terms of theta. So from this triangle then I can say that tangent of theta is opposite over the adjacent side, so this is just the square root of x squared minus 4 over 2. Okay, so I got to replace the tangent here by this right here. Okay, so let me put it down here. So have a coefficient of 32 there, and then I have, okay, so let's look at this and I'll go right here with this answer right here. I cube that, so if I cube it, it cubes the radical, so that would give me then, let me write it as x squared minus 4, and that cube it, that gives me 3/2, because that would be to the 1/2 power. And then you also cube the 2, so that would be 8. And then this is over 3 here. Okay, because of this 3 right here. Okay, this is over 3. Plus, I got, again, the tangent cubed, and that's over 5. So this to the 5th power is x squared minus 4. That's the square root, so if I take it to the 5th power, that would be 5/2 power. And that's over 2 to the 5th power, so that's 32. Okay, now we just have to simplify this. And of course I have my constant of integration here. So the 32 is times this right here, so 8 into 32 goes 4, and then you have the 3, so that's 4/3. And then you have x squared minus 4 to the 3/2. And then that's going to be plus, and I'm going to put that up here. Oh, let me write the whole thing up here then. Okay, so we have then the 4/3 times x squared minus 4 to the 3/2 plus, okay, and then this part right here, when we have the 32, I can multiply this, so the 32 and the 32 will cancel each other off, and that'll just give me a 5 in the bottom here, so this would be 1/5 times x squared minus 4 to the 5/2 power. And this is plus a constant. Okay, so finally you get this answer right here. 4/3 x squared minus 4 to the 3/2 plus 1/5 x squared minus 4 to the 5/2. Again, this is 5/2 power plus a constant of integration. Now again, I point out that had this been just the plain old x instead of x cubed, then a basic u substitution would have worked, and you would have gotten the answer in less than a minute probably. Okay, but that's what it takes in this particular case. Thanks for watching. We'll see you in the next video.